Welcome, and in this video course we are looking at the CyberOps Associate version 1 course. This course is going to cover the skills and knowledge needed for successfully handling the tasks and duties, responsibilities of an associate level security analyst working at a security operations center. The goal of this video series is to help prepare learners for the Cisco 200-201 certification. That's focusing on understanding the Cisco Cybersecurity Operation Fundamentals course, known as CBROPS. Module 7, Connectivity Verification. So we're going to be looking at ICMP and ping. We're going to end with a little bit of traceroute. So first of all, ICMP, what does it do? How does it work? Well, ICMP comes in a few different flavors. We're going to be predominantly looking at ICMP v4 messages. Basically, TCP/IP suite provides messages to be sent in the event of certain types of errors. These messages are using the service of ICMP. The purpose of this message is to provide feedback. A pretty common one is like echo requests. I will echo a response, and then the end device should actually reply with the appropriate response. We set ICMP v4. That is because ICMP v6 provides the same services, but specifically to IPv6 only. While there are a lot of commonalities between ICMP version 4 and version 6, both of them provide host confirmation, destination or service reachability, time and route direction, things of that nature. Those are all pretty similar in all versions. So for host confirmation, essentially ICMP will send an echo message. This will be used to determine if the host is operational or is responding. So the local host will be sent the echo request. The respondent should receive it and then respond. This will use the ICMP echo message in the basic form of the ping utility. Destination or service unreachability. So if we are getting message codes, 0 means not reachable. That means the network is not reachable. 1 means host is not reachable. 2 is protocol, and 3 is port. ICMP v6 has different codes, so we're going to have to talk about those separate. Interesting enough is ICMP v4 does have a TTL function. You can actually see the hop limit in ICMP v4. In ICMP v6, while there also sends a time exceed message if the router cannot forward the packet, ICMP by default doesn't have a TTL field, so it uses the hop limit field instead to determine packet expiration. So ICMP v6, specifically router solicitation, router advertisements, or neighbor solicitation and neighbor advertisements, all 4 of these types of messages, both router and neighbor, are going to use ICMP v6 messages. And this is all about being able to determine neighbor connections. So neighbor discovery or neighbors to discovery protocol. This is new in ICMP v6. These features are not found in ICMP v4. So router solicitation message is between a router and a device. So every X amount of seconds, the router will send a message to all IPv6 devices in a unicast format. That way, any newly powered on device should receive a router solicitation message saying, here's the router information, here you go. they will respond with a router advertisement. Again, I will send a solicitation message once I receive my router advertisement. So the router is it says 200 seconds. That's going to send an advertisement. The solicitation is the response to that advertisement. Part of this is part of the stateless address auto configuration Slack functionality. So that's why we have to understand the relationship between advertisements and solicitations. So for address resolution, or for address resolutions between multiple devices, you will see the neighbor solicitation, and that's normally done in a multicast mode between devices. And the responder, the recipient, to send to a neighbor solicitation will send a neighbor advertisement, and that will be done via unicast. That way you can learn the MAC addresses and IPv6 addresses. Part of this will also help with DAD, duplicate address detection. So similar to what ARP does for an IPv4 network. So again, we just talked about the duplicate address. This allows us to send multicast addressing using neighbor solicitation messages to verify there are no local machines with the same address. So let's go ahead and let's talk about ping and traceroute. So part of networking testing is understanding how to do things from the Windows command line. Go to the command prompt, type cmd. You can type ping google.com, for example. You'll see that we'll get a response. You'll see that google.com got translated to a IP address. Just typing out ping, we can see we get some options. We can modify the count, we can modify the size, the TTL, the type of service. I can actually manipulate the size. So instead of the default 32 bytes, I can send 1400 bytes. I can manipulate IC or ping to do kind of what I want to. Ping is used to test connectivity. We can force IPv4 or we can force IPv6. So I'm actually going to try that. Ping google.com. TAC 6. Well, google.com will not retrieve to an IPv6 address at this time. So I'm going to go ahead and modify that, www.google.com. So right now, my ISP is either blocking Google from being translated or Google's IPv6 server happens to be down. Ping does have a timeout. That's the TTL. If the time actually decrements to 0, it will not keep sending information. So types of connectivity tests performed with ping. You can ping I can ping my loopback address 127.0.0.1. That is just a clever way of saying ping myself. I can ping a remote gateway either via public IP or by domain name, or I can ping my default gateway. ipconfig. My default gateway happens to be 192.168.1.1, so I will ping my default gateway. And it responds. So I've done those 3 general tests for ping. Again, 127.0.0.1 is a loopback address. If we're dealing with IPv6, it would just be ::1. This basically checks the TCP/IP stack and the internal NIC. If this does not respond, then there's something wrong with TCP/IP on the host device or the NIC itself. This is pretty rare, but not that hard to test. The default gateway is again our exit point from the network. So we have to ping our default gateway to ensure that we can leave the network. We can, if we're manually assigning addresses, the default gateway is going to be the address of our router. A remote host. We can ping a remote host via its IP address or its domain name, assuming we have DNS functioning. So we also have this troubleshooting tool called traceroute, and this will actually allow us to test the path things take. So I want to run traceroute against Google. This is going to be the hop by hop, the layer 3 to layer 3 device from my computer to Google. Sometimes traceroute takes a little while, so I paused the video so we could watch this. So here's my local gateway. This is my ISP. These actually are also part of my ISP. And then this is my ISP's internal connection, and I'm assuming their ISP's internal connection. And then we're starting to get to Google's addresses, and those two are part of Google's address. How do I know that? Part of that's just a guess. This looks like a data center link address, and this is part of the same network. So I'm assuming that this is all part of the data center. But this will take us a hop by hop, layer 3 to layer 3 jump between each network segment. That way we can see the time it takes to get between one node and another node. So part of this is called the round trip time, RTT. And traceroute provides a round trip time for each hop, each layered device. If one device is not able to respond, we'll get an asterisk, like we noticed in the screen before. Remember that traceroute has a hop limit, or a TTL. If we're dealing with ICMP v4, it's a TTL. If we're dealing with ICMP v6, it's a hop limit. It doesn't matter what we're calling it. Essentially, there is a life expectancy for this packet. So this is an important slide. This covers the packet format for an ICMP packet. You'll notice that we have a version, a type of service, a length, we have a TTL, we have a source and destination, type of message, and we have codes. Common codes are like an echo reply, a destination unreachable, a redirect, an echo request, or a TTL exceed. Now again, this is for ICMP v4. You know that because looking at the source and destination address, those are 32-bit addresses. You know, 32-bit addresses are tied to IPv4. We do have a lab we're working with in class, and that's all we had for this week. This week we talked about ICMP messages, looking at router solicitation, router advertisements, neighbor solicitation, then neighbor advertisements. We looked at ICMP v4 and ICMP v6, looked at how we could discover neighbor protocols, looked at how TTL works and how ping and traceroute function. If you have any questions, please reach out. Thank you.